Welcome to Chem Help ASAP. Halogenated pi-deficient rings undergo the SNAr reaction, and we can understand this reaction by remembering the chemistry of carbonyls. The top of the screen shows the reaction of an acid chloride with sodium methoxide. The CO pi bond is a weak electrophile at carbon because of the polarized CO bond, a strong nucleophile like alkoxide attacks at the carbonyl carbon, and the electron density of the pi bond is pushed onto the electronegative oxygen. We're now at a tetrahedral intermediate. The electrons of the O- swing back down, kick out the Cl, and reform the carbonyl. The end result is a nucleophilic substitution through an addition elimination sequence. This is chemistry we've already seen. How does this help us now? Well, the bottom of the screen shows an SNAr of 2-chloropyridine with sodium methoxide. The CN pi bond is a weak electrophile at carbon because of the polarized CN bond, a strong nucleophile like an alkoxide attacks the carbon, and the electron density of the pi bond is pushed onto the electronegative nitrogen. We now have again a tetrahedral intermediate. The electrons of the N- swing back down, eject the Cl, and reform the CN pi bond. The end result is a nucleophilic substitution through an addition-elimination sequence. This is exactly the same as what we saw on the top of the slide. Now, these reactions are not identical. A CO pi bond is more electrophilic than a CN pi bond because oxygen is more electronegative than nitrogen. The SNAr requires disruption of an aromatic ring, so that makes the SNAr slower than an acid chloride reaction. Regardless, these are extremely similar reactions. Carbonyl reactions can often help us understand other reactions, and this correlation to carbonyl chemistry is sometimes called a Carbonyl analogy. The SNAr on the bottom line also behaves like other SNAr reactions. The reaction is faster if fluoride is a leaving group. The position of the nitrogen on the ring is important. The reaction works best if the nitrogen is directly next to the halogen or across the ring from the halogen. These positions are analogous to having electron withdrawing R groups in ortho or para positions in an SNAr reaction. Rings with more nitrogens or more electron withdrawing groups are also better able to stabilize the negatively charged intermediate and react faster. This is an application of the Carbonyl analogy to help us understand how halogenated pi-deficient aromatic rings are excellent candidates for the SNAr reaction.